All of you. So today we have a webinar on earthing system design, which is delivered by Hina Madam. She will discuss the earthing system importance, why the earthing system is required, and what are the design factor regarding the earthing system. She has the almost over the 10 years of experience in the power system. She is working as a senior engineer at Takalkar Power Engineers and Consultancy Private Limited. She was working in the field of design of substation. She has already experience of 400 kV transmission line design and 400 kV substation design, and already provided 200 kV DC transmission line to consultancy. So I request Hina Madam to please deliver this webinar and share your experience, ma'am.
Yeah, thank you, sir.
Thank
Good
you.
morning, all of you. Respected sir and ma'am. I'm delivered my lecture regarding earthing system design. I'm working on transmission, Takalka Power Engineers and Consultant Private Limited. Our firm is working on substation and transmission line designs and supervisions, PMC. All are working in our company. So our company is last 15 years, and they are working in consultancy firm in all over world. So now I'm delivered my lectures, earthing system design. Okay. Now you know all are okay, electricity is one of the most important blessing to mankind, right? And we cannot think of world without it. We achieve facility, but it is so dangerous without protection. For this protection, we are using earthing or grounding to the system, right? Now, hello. Now concept of earthing system. The person working at resident, commercial and industrial electrical installations, particularly the operators and personnel who are in close operation and contact with electricity system and machineries should essentially be protected against possible electrocution. To achieve this protection, earthing system of an electrical installation is desired. The design and installation of earthing is to be carried out according to the standard requirements. Now, what is earthing? The process of connecting metallic body of all electrical apparatus and equipment. Apparatus means uh, apparatus means our iron and all that, and equipments means in substation big equipment, CT, PT, current transformer, potential transformer, like that. Equipment to huge mass of earth by a wire having negligible resistance is calling earthing. So grounding earthing and earthing are same, but in some parts people calling is grounding and some people are calling earthing. Grounding the word used in like USA and British and England people using a word is earthing, and we are using sometimes a grounding and sometimes of earthing. Both are same process. The terms earthing means connecting the neutral point of power system or the non-current carrying parts of the electrical apparatus to the general mass of earth in such a manner that all times an immediate discharge of electrical energy takes place without danger. In short, the simple electrical earthing definition is the process of transferring the immediate discharge of the electrical energy directly to the ground by the help of the low resistance wire. Now you can see this picture. We are giving some power from source, and the circuit is through the toaster. Now this toaster is faulty some reasons. There are some having a fault. So our uh, circuit is like source to faulty toaster and then earth. But at the time of we are touching that faulty toaster and we are not providing the earthing. So what happened? We have touched the faulty toasters and our circuit completed through our body and then ground. So happened we are facing a shock. So our circuit is completed through source to faulty toaster and then our body to ground. So we having a shock. So mainly purpose of earthing is to save our human life from danger of electrical shock or death by flow by this current. So to provide an alternative path for the faulty current to flow, so it will be not endanger the users. Right? Now electrical shock contact. An electrical shock occurs when a person's body comes in contact with electrical conductors or live wires of a circuit which is at different potential, which produce potential difference across the body. The human body does have resistance, and when the body is connected between two conductors at different potential, a circuit is formed through the body and current will flow. When the human body comes in contact with only one conductor, a circuit is not formed and nothing happens. Now, potential and current. The higher the potential difference, the more the damage. The effect of an electrical shock is function of what part of body come in contact with each conductor, the resistance of each contact point, the surface resistance of body at the contact as well as other factor. When the electrical contact is such that the circuit path through the body is across the heart, you have the greatest potential of death. Now, human body. Different human body is resistance vary from the 500 ohm to 600 ohms, and it depends on that human body's moisture and then skin moistures. The amount of current that can flow through human body at three different potential differences across the body. The effect of different current level, both alternative current and direct current, the ultimate effect is fibrillation which cause the heart to stop and result is death. Now electric shock, how to affect in our body. When a high voltage is involved, the body is literally cooked and at times of explodes. Body plays important role. Means humans resistivity. You are fatty or thin. That's happened, and human plays other factor also. In man, woman, child. Child's having a very low resistance, so they have very suddenly shock in their body. Now, human bodies. The human body's ohm resistance is 1000 ohm. They are capable for 1000 ohm. So higher than they are them start to shock in our body. Now, when a high voltage involves the body, is literal cook and at times explodes. Now, perceptions level in alternative current and direct current. Precision levels means you are when you touch the some faulty parts and suddenly you panic in your body, means dizzy your body and very vibration in our body, right? So this is a perception level. that is alternate current is 1 milliampere and 2 milliampere. In this condition, maybe we are safe in these positions. Now, no let go level means your hand directly attract towards the current side, right? So, and you pull in your side. So, faulty current is higher than our positions. So, current pull our body towards that side, right? So, this level is 15 milliampere to 300 milliampere. Now, fibrillation level means कि your heart that can lead to blood clots, then stroke, heart failure, other heart related complication in these situations. Means this fibrillation level occurs a zero point 0.2 seconds. So this level is 500 milliampere to 5 milliampere in both conditions. Same as 0.5 seconds. 75 milliampere to 400 milliampere, and human body face a shock, that level is 150 milliampere. At this time we are facing a shock and our heart may be failure in this time. Okay. Now, maximum value of earth resistance. There is a different earth resistance in different parts and different human bodies. So this is a location and place. Now, large power systems, substation means about 220 kV, means 220 kV, 132 kV, 400 kV. In these power systems, our earth resistance is 0.5 ohm. Now, major substations means normal substation means 110 kV, 132 kV. In all these substations, we are using and we are occur one earth resistance. Now, small substation means your kV is below the 110 kV, means 66 kV, 33 kV, 11 kV. In these all kVs are earth resistance is 2 ohm. Now, factories and substations, different factories means chocolate factories and other factories, they are using their earth resistance is 1 ohm. Now, latest steel towers means your transmission line tower, they are one substation to deliver other substation power, that using transmission line tower, which is a 3 ohm. Now, industrial machines and equipment, their earth resistivity is 0.5 ohm. The earth resistance depend upon the moisture content in the soil. Now, there are different types of earthing we are using all places, means plate earthing, pipe earthing, rod earthing, and earth mat. The resistance of ground electrode has three basic components: the resistance of the ground electrode itself and the connection to the electrode, the contact resistance of the surrounding earth to the electrode, the resistance of surrounding body of earth around to the ground electrode. Now, this is a earthing electrode. How to place the earthing electrode? Earthing consists of three basic components. Means this is a earth wire, this is a connector, and this is an electrode. Plate earthing. In this type of earthing, plate either of copper or of GL is buried into the ground at a depth of not less than 3 meters from the ground level. The earth plate is embedded in alternative layer of coke and salts for a minimum thickness of about 15 centimeters. So your level, firstly you have to put in a pit. First is coke layer, then again a salt layer, then after coke layer, salt layer, this 15 centimeter you have to use these layers, and then after you have to use plate earthing. The earth wire is securely bolted to an earth plate with the help of bolt nut and washer made of copper in case of copper plate earthing, and GI in case of GI plate earthing. Means your resistivity is very high, so you have to use copper earthing, and your resistance is normal, so you can use an GI wire. This is a diagram of plate earthing. So this is a pit. This is a pit, and you have to put this plate earthing in the ground depth of 3 meter. That is not less than the 3 meter. And this is a mesh funnel. So you can put the there water and for low resistivity. And this is a GI pipe for this pipe connecting with your equipment and this plate earthing. Now this is a live copper plate earthing. This is a charcoal and salt filled layer by layer, and this is a copper strip. This is a copper strip. The yellow is copper strip, and this is a GI pipe. You can use this GI or as well as copper. This is a live we can use in substations. So this is a copper plate, this is a rod, this is a copper plate, and this is a rod, and this is a GI plate. So we have used this plate earthing in substations. So this is a plate. Now pipe earthing. Pipe earthing is best form of earthing, and it is cheap also in this system of earthing a GI pipe of 30 mm dia and 2 meter length in embedded vertically in ground to work as earth electrode, but the depth depend upon the soil conditions, and there is no hard and fast rules of this. So your soil resistivity high, so you have to use 40 mm dia and 3 meter length, as well as you have to use 100 mm dia and 5 meter length in embedded. But the wire is embedded up to the wet soil. The earth wire are fastened to the top sections of the pipe with nut and bolts. The pit area around the GI pipe filled with salt and coal mixture for improving the soil conditions and efficiency of the earthing system. It can take heavy leakage current from the same electrode size in comparison to the plate earthing. The earth wire connection with GI pipes being above the ground level can be checked for carrying out continuity test, and the when desired while in plate earthing is difficulty. In summer seasons, to have effective earthing, 3 or 4 bucket of water is put through the funnel for better continuity of earthing. So you have to maintain your resistivity. So you have to add some waters, 4 or 3 balti, and your resistivity is coming less. This is a pipe earthing. This is a pit. So you have to prepare 3 meter excavation, and you have to bury the this perforated pipe. Bury this perforated pipe, and this is a funnel, and you have to add water in this funnel. So now you have to prepare these alternative layers. In 15 centimeters is charcoal, then salt, then charcoal, salt, like this. And your GI pipe depends on upon your soil resistivity. Now rod earthing. In this system of earthing 12.5 mm diameter, solid rods of copper 16 mm diameter, solid rod of GI or steel or hollow section of 25 mm GI pipe of length not less than the 3 meter are driven vertically into the earth. In order to increase the embedded length of electrode under the ground, which is sometimes necessary to reduce the earth resistivity to desired value more than the one rod sections and are hammered one above the other. This system of earthing is suitable for area which are sandy in character. This system of earthing is very cheap. This is a rod earthing. This is your pole, means your equipment, and this is a rod. So you have to bury a rod in the ground, and you have to connect with this connector through wire to your pole or equipment. So this type of earthing we are using in substations uh, in rod earthing. So this operation is very easy to use for rod earthing. Now, how to calculate this earthing? Yes, we are go through the some topics and all, but how to apply our earthing in the is design, right? And this design is standard is IEEE 80 2013. This is a system input details requirements. So you have to for earthing design, you have to this top these points you have to carry it out in symmetrical fault current in substation. In all substation means 400, 220 kV and 132 kV. Your fault current is 31.5 kiloampere. Then your in 110, 66 kV, 33 kV, your fault level is 25 kiloampere. So fault level is different, depend upon your kV. So this is a 25 kiloampere. Now your duration of shock for determining your allowable body current. So we have already checked this. Human body, your fibrillations is 0.5 seconds. So this duration of shock is 0.5 second. Now fault current for sizing ground conductor. Your conductor's fault current is 1 second. Now surface layer resistivity. In our Gujarat, then Rajasthan, and different places are resistivity is different. In uh, uh, different that is here is 3000 ohm meter. Now surface layer thickness. Your surface layer thickness is 0.15, which is a standard in IEEE. Now grid resistance depth. Your grid resistance depth is 1 meter. Your soil resistivity is depends upon we already learned about this. His soil resistivity is different places. So here soil resistivity is 9.61. We are using the earth resistance mapping. Now, your grid conductor means your mat, how their depth is, how many depth is in the ground. This depth is 600 mm, and your soil resistivity is very high. So you have to going down in 1 meter. So it's depend on your resistivity. Now, length of grid conductor in X direction and Y direction. This is depend on your substation. Your substation is 220 kV and 132 kV. All our substations width and length is different depends on your kV. So X direction is 30 meter and Y direction is 39 meter. Now spacing between parallel conductor. One conductor, I explain. Just a minute. This is the earth mat, right? So your substation area is this direction is Y and this direction is X. So your spacing is this one conductor to another conductor. Same way, this conductor to another conductor. So this is your substation area, and your mat spread to like this, and that spacing between two conductor is this. So your spacing between parallel conductor is this D, means 10 meter. It depends on your designs and experience. Now, length of ground rod at each locations. We have learned कि your ground rod buried to the ground, which is not less than the 3 meter. So this is a 40 mm dia because their earth resistivity is high. Now, number of rods. How many rods are using for this substation is NR, means numbers. Now, decrement factor for determining IG. That is a 1. That is a 1. Now, how many your incoming lines and outgoing lines, which is a means transmission line is 1 and your distribution side is 2. This is a material property, means you are using copper or GI. It's depend on your soil resistivity. So this is your properties. Means earthing conductor, your kiloampere, your RMS current, maximum allowable temperature, ambient temperature. These all are depends on which conductor are using for this earthing system. Now this is the calculations. Your total length of buried conductor means your area is your substation area is this all, but your earthing materials area is like this, and this means X and Y direction. So L is equal to Lx into Nx plus Ny into Ly plus Lr into Nr. Means required area of ground for earthing grid, required area size of conductor for earthing grid. So these areas is your material area. Now main importance is in touch and step potential. Now your tolerable touch voltage means your touch voltage is 15 kg, means your human weight, and means 50, your weight is 50 kg, and step voltage is step voltage and touch voltage. What is meaning of touch voltage and step voltage? Touch voltage means you this is tower, steel tower. You can just touch to that tower, and at that time, this is in faulty conditions. So this is in faulty conditions. You just touch the steel part, and your voltage in current throwing in your body, in heart, and then in ground. So this is a touch voltage or touch potential. And what is a step voltage? The current passing through ground, and one leg to flowing through another leg and passing through ground. So this is a potential difference. Uh, your potential difference is high, so at that time our shock facing so much, and your potential is very less, your shock is very low. So this is a touch voltage and this is a step voltage. I had share one experience. uh, One operators are taking in reading in control room, and they are standing front of the panel. At that time, meter are damaged due to some reasons, and at that time, earthing mat are not spreading in control room. So that current flowing in ground means that current flowing in this ground, and that operators one leg to another leg passing through the current. At that time, they're standing like this, so potential difference is very high. So they are facing a shock, and at that time, they are their death. So uh, so this very difficult to without providing earthing. So we must be provide earthing in control room also and substation. So operators mainly they are working near to this power systems. So we have to protect to human body as well as. Now I have share you other experience. Uh, the two operators are the two operators were sitting on an iron chair in the control room. One operator's feet were on the ground, while the other operators were seated in a chair. There was a fault in the control room, and the operator whose feet were on the ground had his circuit completed, so he was shocked, while those whose feet were on the child and other operators not shocked because of their leg in the chair. They are not touching the ground. So uh, two conductors are touching, so we face the shock. Now, main importance things is grid resistance. Grid resistance always we have to maintain below the 1 ohm. So we can able to uh, live in substation. So we have to maintain this RG grid resistance below the 1 ohm. Now we have to check these four main things, which is a earthing ground area. Your earthing ground area must be less than to the required area, means your materials area. Now grid resistance always in below the 1 ohm. Touch voltage always less than the calculated touch voltage, and step voltage as well as we have to less than to the materials step voltage. So this is a pipe earthing ground mat. This is a, so we have to spread like this. and this is a strip earthing. This is a area, and this is a strip, and two between two conductors spacing is like this. So this is design depend upon your soil resistivity and your design and your area. So these applications, you can apply this earthing in telecommunication, transmission line, in tower, through earth wire and OPGW, substations and power generations, transformer neutral earthing, lighting arrestor earthing, equipment body earthing, water treatment plants, heavy industries, college, hospitals, banks, residential building. So earthing is most uh, thing you have to provide the earthing, so we can save in this electricity. So you provide the proper earthing in all apparatus in substation as well as in our residence area. So thank you very much.
Thank you, madam. So next, we have taken the question answer session.
Yeah.
So, madam, one question is from student side. His name is Janil Shah, and his question is it feasible to use an isolating transformer just beside a distribution transformer instead of performing earthing? I will post a question in comment section.
Just
Hello.
Yes, sir. Hello.
hello.
Ma'am, I have just posted the question into the chat box. So the question is, I will repeat this question. Is it feasible to use an isolation transformer just beside a distribution transformer instead of performing earthing?
Just a minute.
Hmm. And we have also have an expert, Mr. Prakash Shah, for giving the information or solving the question. So Prakash sir.
Hello.
Yes, sir.
Hello. Are you able to hear me?
Yes,
Hello.
sir. Yes,
Yes,
yes.
sir. Hello. What is the question?
Sir, question is that is it
Yeah.
feasible to use an isolation transformer just beside
Hmm.
a distribution transformer instead of performing the earthing?
By isolation transformer, what is the purpose for you? Why do you want to install the isolation transformer?
Hmm.
We should know
Uh,
the purpose, ne?
hmm.
हेलो मिस्टर
Yes,
परमानंद,
sir.
क्या नाम है आपका?
Yes, sir. Parvez, sir.
गुलाम।
Parvez. Parvez.
हाँ हाँ, तो
Sir,
what is the
question is
purpose
the
of
student,
using
sir.
the isolation transformer?
Yes, sir.
At least I should understand the purpose, and then I can reply.
Sir, this question is asked from the student side. His name is Janil Shah.
Yeah, yeah. Okay, any more question?
Yes, sir. Another question is
Yeah.
from Ritul Panchal. The
Okay.
question is, sir,
Yes.
uh, why are electrical shocks are different for AC and DC?
Okay, good questions. Hina, you go to the slide where we have
Yes.
shown the AC and DC.
Yes, sir.
Current carrying capacity, this milliamperes are there. You just
Mm-hmm.
change the slide, you go to that one slide. Okay, I got the question. So here is the chart where you can see the for the perceptuals or the fabrials or others, the current is different. When in AC, what is happening? You got the shock. In that case, the sinusoidal wave is there. So in 1 second, you will get 50 times. on and off. You will get the shock, you will leave the shocks. Therefore, the currents are different. That is the main purpose. Okay. In DC, once you got this, you will get the continuous flow of current. तो आप वहां पे चिपके रहेंगे. अब वहां से आगे वहां से छूट नहीं सकते हो डीसी में. इन केस ऑफ एसी देयर इज चांसेस टू leave from the electric contact. That is the main difference. And second thing, in the DC, the voltages are very poor, very, very less. While in case of AC, the protections are more in AC when voltages are increasing. Well, in case of the DC, if you are a 48 volt or 110 volt or 220 volt, that's all. Then uh, that's all. But for 500 kV HVDC and 800 kV HVDC, protections are there, relays are there, so they are operating very nicely. Yes, are you okay, Mr. Panchal? Hello.
Yes, sir.
Okay.
Sir, our next question is, what can be the earth resistance if a large substation is located at hilly area? Will 0.5 ohm be applicable for the system?
Gentlemen, let me say there are three things deciding the resistance. One is the voltage. What is the voltage level? What is the fault current? So all these things, here I have written the large power stations, or say a large power stations means you can take the examples of the your 1200 megawatt power station at Kevadia College, or you can take the examples of the Vadakpuri power stations where the 800 megawatt unit is installed. So in that case, 0.5 ohm is sufficient. But in small substations or small power stations like 10 megawatt solar power plant in what we call a Sama, so it can have a 1 ohm or 2 ohm. That is sufficient.
Okay.
Yes.
Okay, sir. Our next question will also from Kritul Panchal. How will be the earthing system behave if the spacing between two ground conductor and not uniform?
No, I am not getting it.
Sir, you just written into the chat box.
Yeah.
How will be the earthing system or earth current behave if the spacing between two ground conductors are not uniform? Between two ground conductors are not uniform.
So okay. So there may be a loose connection. Size of the conductor may be different. Secondary deteriorations in the conductors may be there. Connectivity is not there. If it is a charcoal and salt is there, so in that case also there is a difficulty. There's a proper combination is not there. Water is not added and so on. Yes, sir.
Yes, sir. And sir, one last question from Yax Patel. He's from Third Sem Electrical. What is the difference between normal earthing and grid earthing?
Normal earthing and grid earthing. Okay, good. So normal earthing, if you see your residence, it is a normal earthing pipe type or road type earthing. But if you visit to our 400 kV transform the 400 kV switchyard, or you can visit our 66 kV switchyard, in which this odd grid is buried in the substations, while at the residence, commercial or industrial, we are not doing. But if you take the examples of the testing bed, if you go to the ADA, where this your testing bed for the short circuit test is there, in that case you have to construct the earthing grid, so that you can have a minimum earth resistance and have a very good flow of current, and so that the your uh, fault current will flow to the relay, and that will give you a proper protections. Yes, sir.
Yes, sir. Our next question is, sir, are there any special precaution or practice to be taken care when the designing an earthing system if the substation is in area with frequent lighting stops?
Frequent
Frequent lightning.
frequent yes.
Lighting. Sir, I will repeat the question. Are
Yeah.
there any special precaution or practice to be taken care when designing an earthing system if the
Yeah.
substation is in area with frequent lighting?
Frequent spell out
Lightning.
lightning spell.
Lightning. Lightning. NING, lightning.
Lightning strokes. Okay,
Lightning
but
strokes.
if you see the design of the substations for a even small substation of 33 kV or 66 kV, or if you go for the 400 kV substations, also there is one diamond is to be constructed above all the equipment, and that will take the care of the lightning strokes. If you see the substation designs, even in the near aerodrome, if you go to the Ahmedabad, there is one substation is a special color they have given, and they are constructing the now it is a made compulsory or it is a mandatory to have a diamond on the substation where on which the in crossing the grids are constructed, and that is known as diamond earthing, and that will take care of the lightning strokes coming from the sky. So daily 4 to 5 persons have died in our India due to lightning. This is the situation. If light more is there, then your this diamond size will be, or more connection should be there, crossing should be there. Just like a star, you have to construct.
Okay, sir.
Huh? Okay.
And one last question.
Yes,
How
sir.
will the earthing system?
Yeah.
Okay. This question is covered, sir.
Okay.
Hello, sir. There is a one question from Pritur Panchal.
From where?
Pritur Panchal, one of our alumni student.
Okay.
The question is: suppose a transmission line installed in C area, how to
In C
measure?
area.
C area.
No,
How to measure earth resistance in C?
in C area, I am not getting you.
C, the Rio. Suppose a transmission line installed in
Panchal, can you explain me? Rishil, वो पंचाल जी है? Is he online? No.
No, sir. He is on FBL.
Okay. So in the sea, or if you take the examples of the river, Narmada river is there near Bharuch. So there is a piled foundations. So there is no contact with the. So we have to take the earth resistance at the muffing area of the tower, and we can measure the earth resistance, because in the sea or in the river we are doing the pile foundations, and we can have a measurement of the earth's resistance on the back to back angles are connected, and we can have a earth resistance of that one, and this piles goes to the mother soil of the either river or either this one. And second thing, we are installing a marine cable in the sea. If you go to the Dwarka, so there are marine cables are there. And if you go to Goga near Bhavnagar, so we have installed 66 kV marine cables are there, on which this armoring is there, and we can measure the earth resistance of the such installation which is under the sea or under the water. Yes, this is it clear? Okay.
Yes, sir. There is one question of our faculty, Azhar Sheikh, sir.
Yeah, okay.
So, question is there any innovation that we do in earthing so the students can make a
Take-
project on earthing?
Okay. So there are so chemical earthing is there. I think Hina, have you covered the chemical earthing or not?
No, sir.
Okay. So nowadays there is a chemical earthing is there. So what I have seen in the slides. So they have taken the charcoal earthing. So charcoal and salt we are using. Now this chemical earthing is after the charcoal earthings and other things, there was a development for using the lignite powder and others, and it is the bentonite. It is known as bentonite earthing is there. And third one, which is the latest development, in which this charcoal earthing and the salt earthing and also bentonite earthing, instead of charcoal and salt, we are using the bentonite material, which is available in the Kutch areas. About 70% share is there of the bentonite throughout the India. So this bentonite earthing, but you can have three examples with this bentonite. What is the earth resistance with the charcoal and salt, and third one is the chemical earthing. So this manufacturers of the chemical earthing are there in Surat areas and other things, but what exact chemicals they are using, they are not telling us. So this chemical earthing is there. So this is the latest development, and your students can have a project on chemical earthing. One of the student of our college, that is Parul College, he has done the project on the 400 kV switchyard and what is the earthing, and what is the earthing of the each earth pit, and how it can be improved. So such type of project they can get. So you can note down the chemical earthing. Bhagat sir, you can this bentonite earthing and chemical earthing that can be taken as a project. And our company, yeah, Hina's company, that is Takalkar Power Engineers and Consultant, can assist you to provide the details and data, and also the guide the students who are interested for taking the projects. Yes, sir.
Yes, sir. Thank you, sir.
Okay, welcome.
That's all for the question answer. Parvez sir, is there any question from student side?
No question, sir.
Okay.
Okay.
So,
Hina, would you
on-
like to share something? Okay.
yeah.
Yes.
Hello.
Hmm.
Yes, sir.
Yes, any question now remain with you?
No, sir.
Okay, we have answered each and every questions. Okay, we have tried to give the your satisfaction to all the questions, but Hina is given her Gmail ID or email ID, and you can contact our this Rishil sir or Parmeshwar or any others for further details.
Yes, sir. So, on behalf of Parul University, I, Rishil Bhagat, very much thankful to Hina madam and Prakasa sir for giving her valuable time and sharing knowledge in the field of earthing system and earthing design. So, it is very useful to our students in present and in futures. So, very much thankful to Hina madam and Prakasa sir. Thank you very much.
Yes.
Okay, thank you all of you
Thank you.
for
Thank you, all
joining
of you.
the webinar.
Yes, sir.
Thank you.